Welcome dear friends. This is an interesting video on use of steam tables. We will be solving very simple numericals using the steam tables. So that is objective. Let us remember that certain terms were used for explaining the concepts of steam. One was saturated liquid, which is state 2. The other was dry saturated steam, which is the state 4. The third was the wet steam, which is the state 3. And state 5 was a superheated steam. We consider the heating of water from 20 degrees centigrade up to the boiling point at atmospheric pressure, which is 100 degrees centigrade, and we call that as sensible heating. We said that when the water reaches its boiling point, the steam formation happens, the water starts boiling, and it becomes wet steam. So a saturated water becomes wet steam, and then gradually at state 4 it becomes dry saturated steam. If you heat the dry saturated steam further, it becomes superheated. So from the steam table perspective, we would be using the term F to denote the state 2 and G to denote the state 4. We would be using the term dryness fraction to denote the quality of the wet steam. At state 3, we would say that the steam is having certain dryness fraction X. At state 2, the dryness fraction is taken as 0 because it is saturated liquid, and at state 4, the dryness fraction is taken as 1 because it is dry saturated steam. The typical problems are you need to find the specific enthalpy, specific volume, specific entropy or boiling point at the given pressure. So I had taken some representative pressures for the problem solving. One is the pressure of 0.1 megapascal, the other is the pressure of 1 megapascal, third is the pressure of 10 megapascal, and finally a critical pressure of 22 megapascals. Note that 0.1 megapascal is 1 bar, 1 megapascal is 10 bar, 10 megapascal is 100 bar, and 22 megapascal is 221 bar. So with this understanding, and by knowing that the state is saturated liquid, we need to refer to the properties from the steam table as HF, VF, and SF for the specific enthalpy, specific volume, and specific entropy. And if it is dry saturated steam, from the steam table we need to look for Hg, that is specific enthalpy of dry saturated steam, Vg, specific volume of dry saturated steam, and Sg as specific entropy of dry saturated steam. For wet steam, we need to use the expression HF plus XHFG, VF plus XVFG, and SF plus SSFG. Okay. So with this understanding, let us arrive at a simple problem. Suppose the problem is that you need to find the boiling point of water at 0.1 megapascals. So what you would be doing is that you would be referring to the steam table and looking for the saturation temperature. So that saturation temperature, for example, let us see here. Let me show you another screen where there are the steam tables. Okay, so what you see is the steam tables here, and let me try to show you the saturation temperature here. Okay, so the saturation temperature at 1 bar, okay, at 1 bar, so you need to just swap the tables. Now I'll be rotating it. Just a minute. What you see is here, the steam tables are in front of you, and I am trying to rotate the steam tables so that you're just in a position to read them. Okay, so look at this. You see that first table is saturated water and steam temperature table. This is arranged on a temperature basis. So the first column is temperature and the second column is the saturation pressure. I would go to the pressure table directly. This is a temperature table. I'm going to the pressure table, which is a table 2 in my steam table. Okay, so this is a pressure table you see. So the pressure table, as you see, the first column is the pressure column and the second column is temperature column. So my pressure is 0.1 megapascal, which is 1 bar, 1 atmospheric pressure approximately. So you see that when the pressure is 1.01325 bar, the corresponding temperature is 100 degrees centigrade. Okay, so it means that the water would boil at 100 degrees centigrade if the pressure is maintained as 1.01325 bar. Similarly, if you are asked to find the boiling point at 10 bar, which is 1 megapascal, just go around. Let us go to 10 bar. So you see that 10 bar, the boiling point is 179.9 degrees centigrade. It means that the water would boil at about 180 degrees centigrade if the pressure is 10 bar. Let us go to 100 bar now. 100 bar means 10 megapascals. So you see that at 100 bar, the boiling point is 311 degrees centigrade. And let us go to the critical point, which is 221 bar. So 221 bar, look at this, the temperature is 374 degrees centigrade. Okay, so if we are asked to find the boiling point, just we need to go to the pressure tables and look for the corresponding temperature values, and that is a boiling point. Okay, so the pressure and the corresponding temperature is the boiling point. We don't use the term boiling point, we use the term saturation temperature. Now suppose you are asked to find the specific enthalpy at 10 bar. Okay, so specific enthalpy of saturated liquid at 10 bar. So 10 bar is seen over here. 10 bar, we need to look for HF value. So 10 bar HF value is the specific enthalpy of saturated liquid. Look at the value, and that value is 762.6 kilojoules per kg. Okay, instead of saturated liquid, if you were asked to find the specific enthalpy of dry saturated steam at 10 bar, so instead of referring to HF column, we need to refer to HG column. So HG is at 10 bar, you look at this 10 bar, which is 1 megapascal. HG value, you would see that it is 2776.2 kilojoules per kg. Okay, so one can find the HF value and HG value at 10 bar. So any other pressure, you can find the corresponding values. If you look at the value of HFG, you would always find that the HFG is simply a difference between HG and HF. Okay. For example, at 10 bar, this 2013.6 is nothing but the difference between 2776.2 minus 762.6. Similarly, if you take a pressure of 6 bar, the HFG value, which is 2085.1, is a difference between 2755.5 minus 670.4. Okay, so if your HFG value is not given in the steam table, you can simply use the value as Hg minus Hf, which is nothing but HFG, and HFG is the latent heat of vaporization. If you are asked to find the specific volume of liquid at 10 bar, look at the value of Vf. Okay, so Vf at 10 bar is 0.001127 meter cube per kg. Right? If you are asked to find the specific volume of dry saturated steam at 10 bar, look for the Vg value. So Vg value is 0.19430 meter cube per kg. Okay, this way we can find the specific volume of saturated liquid as well as dry saturated steam directly from the steam table. Okay, look at the entropy column now. Suppose I will take some other pressure now. For example, let me take a pressure of 20 bar. So 20 bar, if you are asked to find the specific entropy, so look at the steam tables. At 20 bar, you find the value of entropy as 2.447 as the specific entropy of saturated liquid. If it is given that the steam is dry saturated and it is at 20 bar, then look for the SG column. SG column is 6.337 kilojoules per kg Kelvin. SFG is SG minus SF. SFG is SG minus SF. At a critical point, if you see at critical point, look at this value 222.1 or 221.2, you will find that this HFG value, latent heat of vaporization, HFG, that is Hg minus Hf, is equal to 0. So that critical point is a point where the latent heat of vaporization becomes 0. Now, if you just scroll with the steam tables, you'll find that as the pressure goes on increasing, the boiling point also increases. Okay, if you're at pressure 13 bar, the boiling point is 191. At a pressure of 26, it becomes 226. At a pressure of 36, it becomes 244. At a pressure of 50 bar, it becomes 263.9. So as you go on increasing the pressure, the boiling point increases. So these tables are called as saturation tables, saturated water and steam tables. And now you are comfortable to find the specific volume, specific enthalpy and specific entropy of saturated liquid and dry saturated steam. What if the steam is wet steam? So if the steam is wet steam, then you need to use what is called as the expression for wet steam using the concept of dryness fraction. Okay, so if the steam is wet, then we need to use the expression HF plus XHFG, VF plus XVFG, and SF plus X uh, uh, SFG for finding the corresponding enthalpy, specific volume, and specific entropy. Okay, so let me just show you this calculations. This first slide which I had shown you, I already explained you that how do you find the boiling point using the steam table at 0.1 megapascal, 1 megapascal, 10 megapascal, and 22.1 megapascal. I had shown you that from the steam table you would get directly the boiling point as 100 degrees centigrade at 0.1 megapascal. 1 megapascal it was 180, 179.9 degrees centigrade, which is approximately 180. At 10 megapascals, I had shown you from the steam table that it is 311 degrees centigrade, and at critical point, the critical temperature was 374 degrees centigrade. Okay, I had also shown you how to find the enthalpy of dry saturated steam at 1 megapascal and 10 megapascal, which value you can confirm from the steam table as Hg is 2776, and at 10 megapascal that value becomes 2727. So we were talking about wet steam, and for wet steam with the dryness fraction 0.8 at a given pressure of 0.1 megapascals, the point would be between B and C but closer to the saturated vapor line because the dryness fraction is 0.8. So in that case, we need to use the expression HF plus XHFG. Okay. So for example, if you refer to the steam table at 0.1 megapascal, the value of HF would be 419 plus X into HFG is 2257. Okay, this way we find the enthalpy of wet steam. Similarly, at 10 megapascals, you can look from the steam tables that the value of HF is 1408, the dryness fraction is given as 0.8, and the HFG value is 1319. Okay, so this way we need to find the enthalpy of wet steam. Similar expressions can be used to find the specific volume of wet steam and specific entropy of wet steam. For example, if the specific volume of wet steam is to be determined at 0.1 megapascals with the dryness fraction 0.8, we need to find the specific volume at 0.1 megapascals, which is 0.001 cubic meter per kg, and Vg value also you can find as 1.673. Okay, so at 1 megapascals, the Vf is 0.001 and Vg is 0.195. And you just use this expression as Vf plus X into Vg minus Vf, because in wet steam, Vg is 0.195, Vf is 0.001 into 0.8 plus Vf is 0.001, we'll get the specific volume of wet steam. Same goes with the specific entropy. SF plus XHFG is the expression. So for example, if you take a pressure of 0.1 megapascals, as I had shown you from the steam tables, the value of SF is 1.307, SFG is 6.048, and then you need to substitute the value in this expression, SF plus XSFG with the dryness fraction as 0.8, and you will get the corresponding specific entropy. This way, we will be using the steam tables for finding the wet steam enthalpy, wet steam specific volume, and wet steam specific entropy. Similarly, as I said, we can use the steam tables for finding the specific enthalpy of saturated liquid, specific volume of saturated liquid, and specific entropy of saturated liquid by referring to HF VF and SF columns respectively. And if it is dry saturated steam, again it is very simple. Just look for Hg value, Vg value and Sg value. What if the steam is superheated? So if the steam is superheated, let me just show you again the steam tables. You need to go to the superheated steam tables. Okay, so there is something called a superheated steam tables. Let me show you that superheated steam tables. Okay, so this is, for example, the specific enthalpy of superheated steam. So for example, if you are given a pressure of, let us say, 1 bar, you know that the boiling point is around 100 degrees centigrade, and if the temperature is mentioned as 200 degrees centigrade, so you can read at 200 degrees centigrade what is the specific volume. So that is 2875.4 kilojoules per kg Kelvin. Okay, so this way we can read the specific enthalpy of superheated steam by using the superheated steam tables directly. Similarly, there are specific entropy tables for superheated steams where you must know two parameters. One is you must know the pressure and you must know the superheated steam temperatures, and accordingly directly we would get the specific entropy, specific volume from the steam tables. Okay, so I hope this is very clear to you. The advice is you need to use the steam tables and practice a lot